AP Calculus AB, Unit 4, Day 4. These are the answers to the assignment. Should check them real quick if you haven't already. Pause the video if you need to, and then I'll show you the work. So pause the video if you need to. Move it up. Pause the video if you need to. Check these. These problems in the back, 20 and 23, you had to show quite a bit of work for these. Do them a long way. I did 20 in the notes. Okay. Last problems, I want you to use a shortcut. I want you to use the derivative rules to go ahead and get these answers. Recognize that you've been given the definition derivative in a limit disguised as in a limit. So, okay. So the front page is a lot of review of problems that we've been doing for several days now. Graphical limits, what's the value at f negative 8? Well, assume that most of these should be lining up to nice values. That's 5. Limit as you approach negative 8. Left and right both agree on 3. Limit as you approach negative 6 from the right side. It's going to negative infinity. Technically does not exist, but I want you to write negative infinity. As you go to infinity, this is end behavior. It appears to be approaching positive 1 on the right side. Horizontal asymptote. As you approach negative 3 from both sides, we're going to say does not exist. I know that on both sides, it is going to positive infinity, and you might be like, oh, they agree, so we should write it. No, not in that. One-side limits I'm all right with. Go to infinity. So let's not say that. Even though I think on my homework answers I have it. I don't want that. Okay, now this one's a derivative. As you approach 6 from the right side, negative 6 from the right side, what's the derivative? It's going to positive infinity. No, it's negative infinity. The y value is going to negative infinity. The slope is a positive slope. It's going to infinitely steep. G, true or false. Usually I want you to show me some work to support true or false. As x approaches 0, the function equals 0. Well, that's sort of the definition of continuity there. But you could say, okay, well, the limit as x approaches 0 is 2, and the value of f of 0 is 2. So yes, it's true. So you could just write down the values. True or false. As limit as you approach negative 6 from the right side, the function goes to negative infinity, right? And then the slope as you approach negative 3 from the right side is going is negative infinity. So I guess it's true. That's kind of probably bad to say is true because they could be different kinds of infinities. Anyways, the left side of the right side negative 3, that's a negative slope. The functions are going to positive infinity, but the slope is negative there. So, anyways, okay. This, we always just plug the numbers in first. 2 cubed is 8, minus 2 is 6. No issues there. Number 3, it's just going to be 4 no matter what. Number 4, sine of pi over 3, sine of pi over 3 over 1 minus cosine of pi over 3. Sine of pi over 3 is 0, pi over 6, pi over 5, 3, 0, 1 half root 2 over 2, root 3 over 2. Cosine pi over 3 is, the angles are 0, pi over 6, pi over 4, pi over 3. Cosine goes from the top, 1, root 3 over 2, root 2 over 2, 1 half. So then that's going to be 1 half. And it's going to be root 3 over 2 times the reciprocal. And the answer is going to be root 3. I want you to simplify the trig ones. If you plug 2 in here, you get 0 over 0. You could do L'Hopital's rule, but I think it's also easy enough to factor the whole out. You take a 2 out. take a 2 out. That's what you get. And then we're trying to get 2 minus the square root of x here. So I'm going to do, we can do the square root of x minus 2, square root of x plus 2. And then we could take a negative out to get it square root of x minus 2 on the bottom. So you're going to have to do something. You can't just cancel the 2 minus square root of x with the x minus square root of 2. They're not the same. So that should be next. So we have a 2, a negative left over, and this. So the square root of 4 is 2 plus 2 is 4 times 2 is 8. Divided by negative is negative 8. Okay. Number 6, plug 2 in, you get 0 over 0. So take the limit as x approaches 2 of x plus 2, x minus 2. Cancel the whole out. Plug 2 back in, we get 4. You could do L'Hopital's rule. It's going to be 2x over 1, which would also give you 4. That was pretty nice. Okay, number 7, plug 2 in, you get a minus 2 is 6 minus 6 is 0 over 0. You could do L'Hopital's rule. L'Hopital's rule, you do the limit as x approaches to the derivative of the top, 3x squared minus 1 over 1. If you plug 2 into that, you get 11. It's pretty nice, but you also need to be able to do it the other way. So you're probably going to do some synthetic division here. You're going to have to do it both ways on your next test. 1, 2, 2, 4, 3, 6. Should get a 0 here. So what we have is we have a limit as x approaches 2 of x minus 2, x squared plus 2x plus 3 over x minus 2. There's the hole in the graph. Plug 2 back in. 4 plus 4 plus 3 is 11. You got to be able to do it both ways. 8, we're pushing 2 to the right side. That's going to give you 5 over 8 minus 8 is 0. So this is some kind of infinity, but is it positive or negative? So the best thing to do, I think, is to factor this on the bottom as much as you can and realize we're approaching 2 from the right side. Now that's just going to go to 4, but this is going to go to 0. And it's like you're plugging in 2.00001, so that's going to be negative. So that's a negative 0, so we're going to negative infinity. Okay. Number 9, you get 9 over 0, similar issue. It's going to be some kind of infinity. It's a positive or negative. Plugging in 3 plus, 3.0001, something to the right of 3, barely. It's going to be negative. It's going to be negative. Those are definitely problems you can't use L'Hopital's rule on. They don't give you the indeterminate form. This is a cube root. Now, top's going to be negative infinity. Bottom's going to be positive infinity. So we should get a negative answer. This is the dominant term, and this is the dominant term with cube roots. So it's really like a cube root of negative 2x over cube root of 16x. Or ignoring the other term. So they're the same degree. So it's really just going to be the cube root of negative 2 over the cube root of 16. Cube root of 16, we could take an 8 out, right? And then there would be a 2. So that would be a negative cube root of 2 over 2 cube root of 2. And the cube root of 2's cancel, and you get negative 1/2. Hey. There's other ways you could do that too. But 11, plug infinity in. This is a dominant term. This is a dominant term. You're going to get positive infinity over negative infinity. You should get a negative answer. Now these terms are the same, so it's just going to be a ratio of their coefficients, 8 over negative 6, which is negative 4/3. And that's a horizontal asymptote. Here, dominant terms, it's going to be positive infinity over positive infinity. Should be a positive answer. This one's bigger than the top, so it's blowing up on the bottom. It's going to go to 0. This one will go to negative infinity, dominant term. This is going to be negative infinity over. Now the negative infinity gets squared, which makes it positive, and then it's negative, and then you're taking the square root. It's going to be imaginary. It's going to be the square root of negative infinity. So that's going to be imaginary for sure. So The answer is does not exist. Okay. All right. Next one. 0 over 0. There's a hole. This is that one we were talking about yesterday or in the notes. Let's see. If it's sine of something over the same thing, it goes to 1. But this doesn't have 3. This has to have the 3. And to make that happen, you got to multiply by an extra 3 on top. That's going to be 1. So the answer is going to be 3. Okay. This one is going to give you, this one's going to be sine of 0 is 0 over cosine of 0 is 1. The answer is 0. Nothing weird there. Don't make problems harder than they need to be. 0 over 0. Got issues. Just plug it in, see what happens. Just like the last one, it worked out really easily. So we're going to go ahead and break this up and try and get that pattern to happen. So I find it easier to break it up like this. And then we want a 3x here and a 4x here, which is fine. The x's balance each other. The 4, I need an extra 4 on the bottom. The 3, I need an extra 3 on the top. Now that's going to be 1. That's going to be 1. So it's going to be 3 over 4, 3/4. That's the work I want to see. Next one, if you plug 0 in, its tangent is sine over cosine, which might actually be helpful for another step later on if we have to keep going. So this is going to be 0 over 0. So what I'm going to do is I'm going to break this up. I'm going to put I have the sine 2x. I'm going to make a fraction out of that. I have the sine 3x, multiplied by the reciprocal, and then the cosine 3x ends up on top. Now here's the deal. The cosine doesn't matter. We don't need to do anything that. Don't do that. That's going to just be 1, right? But I need a 2x here and a 3x here. The x's cancel, balance each other out. The 3, I need an extra 3 to bounce out. The 2, I need an extra 2 to bounce out. That's going to be 1. That's going to be 1. There's an extra 2 and a 3 and a 1 left over. It's going to be 2/3. Okay. 18, limit as x approaches 4. Technically, we should show one-sided limits. So as 4 approaches from the left side, that's specifically going to be, I guess it's going to be the same on both sides. It's going to be the same function. So it's going to be 19. And then from the right side, it's also going to be 19. So it's going to be 19. Both sides agree. Usually there's different functions on the left to right side, so that work kind of makes even more sense. This one, if we go to infinity, it's going to be positive infinity over positive infinity. This term is going to become negligible because -1 to 1 is nothing compared to that. We don't need sandwich theorem on this one, I don't think. These are the dominant terms. They have the same they have the same degrees. It's just going to be ratio of their coefficients. 2 over 1 is 2. So, that's it. Okay. On the back, we did problem 20 together. And that's the work that you need to show for it. And that's the kind of work that you're going to be doing for all these problems. So I guess write small. You're going to have problems like this on future assignments and also in your next test. So we're using this particular definition of derivative, which is a symmetric difference quotient, used to point on the left and right. So the first step is to just plug x plus h in to this. X plus h to the 4th power plus x plus h goes there also, minus, then we plug x in, and it's going to be x to the 4th plus x, all over 2h. So now we're going to expand this. So we're going to use that Pascal's triangle, which I wrote up there. Again, you should be able to create this Pascal's triangle pretty quick on your own. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You go as far as you need to. This is 0th power, 1st power, 2nd power, 3rd power, 4th power. Also, the second number is always going to equal the power. So that's one we want to use. This is going to be a bit messy. So the first one is going to be 1 x to the fourth h to the 0 plus 4 x to the third h to the first plus 6x squared h squared plus 4x to the first h to the 0 plus 1 x to the 0 x should be h cubed x to 0 h to the fourth plus x plus h, right? Minus x to the fourth minus x. And there should be a limit here also. I keep forgetting to write that. I will take points off on your test if you don't write the limit. So, okay. Now, any terms clean up. We have an x to the fourth and a minus x to the fourth. We have, that might be it. Let's see. We can combine like terms. And so let's see. Is there anything? Okay, let's see. Oh, you know what? I messed up. Shoot. This is supposed to be x minus h in here to the fourth minus x minus h. Oh my gosh. I got a bit more work to do here. Okay. So let's get rid of that for a second. So it's going to be minus. So we got to do that binomial expansion again. 1 x to the fourth negative h to 0. The negative belongs with it. Okay. Plus 4x cubed negative h to the first plus 6h x squared negative h squared plus 4 x to the first negative h to the third plus 1 x to the 0 negative h to the fourth minus x plus h, and then we're going to have to distribute this subtraction to all of that. So we have an positive x to the fourth and a negative x to the fourth here, and these negatives, when they have even powers, become positive. So then we have a 4x cubed h and then a plus 4x cubed h, because that's negative times a negative, so that's going to be 8x cubed h. And then, so we got those taken care of. And then we have a 6x squared h squared and another 6x squared h squared. That one's going to be positive, and then we're subtracted, so they're going to cancel each other out. Then we have 4x h cubed and a negative 4x h cubed that gets subtracted, so they get added, so that's plus 8x h cubed. Then we have an h to the fourth and a we have an h to the fourth and then a negative h to the fourth that gets a positive h to the fourth that gets subtracted, so they cancel each other out. And then you have an x minus negative x, so that's a plus 2x. And then you have an h minus h, so they cancel each other out. And so this is what we have left. And so now, hold on with the x's. I think everything should have h's in it. Let me look at this. That's let's see, x minus h. I went ahead and distributed that, and then you distribute the next subtraction to all of it. And you know what I messed up? This is a plus. I wrote a minus there. It's supposed to be plus. So this should be plus, this should be minus. The x's cancel each other out. The h's get added up. Okay, so I knew something was wrong. I mean, you'll know if you mess up. Everything should have h's when you're done so that you can factor the h out. out of everything. And I would just factor that, first of all, 8x cubed plus 8xh squared plus 2 over h. The h's cancel. And so if you plug h equals 0, and again, we get, oh, there's supposed to be 2h on the bottom, by the way. So there's still 2. So that's going to be 4x cubed. When you plug h equals 0, and that term goes away, but then we still have a 2 divided by 2 is 1. And if we think about it, what should the derivative of x to the fourth plus x be? 4x cubed plus 1. So you should know. You got it wrong, right or wrong. Next problem, you guys don't really know the derivative rule that you need for this one. So you're not going to necessarily know if you got it right or not. But let's see if we can set it up. Limit as h goes to 0 of 2 over. Now we're going to plug x plus h into there. I'd put it in parentheses. Minus, you're going to plug x minus h in there. Put it in parentheses. All over 2h. So this one's a little messy, but we're going to try and clean it up. You're going to have to give these guys least common denominators. Now, the first thing you should do is do minus x minus h. They don't have least common denominators. They look close, but they're slightly different. So what you're going to need to do is go ahead and multiply the top and bottom of this one by that one, and multiply the top and bottom of this one by the other one. So it's going to be 1 minus x minus h, 1 minus x minus h, 1 minus x plus h, 1 minus x plus h. Okay. And I'm going to move this to the top, or I'm going to multiply by the reciprocal of that, get rid of the complex fraction part of it. So on the top, you need to multiply these out. That's going to be a 2 minus 2x plus 2h. This is going to be a minus 2 plus 2x plus 2h all over 2h, 1 minus x minus h, 1 minus x plus h. I don't need to multiply the bottoms out. That's fine. The top, though, I need to. Now, the 2's cancel. The negative 2x and positive 2x cancel. The 2h and 2h add up, which is kind of what we expect to happen on these, right? Like all the non-h terms should go away. Otherwise, we're going to have problems still. So we have 4h over 2h, 1 minus x minus h, 1 minus x plus h. And the 2 reduces with the 4, and the h is reduced. So then when we plug in limit as h goes to 0, we get 2 over 1 minus x, 1 minus x. Or if you want, you could write it 2 over 1 minus x squared. That's the derivative of that. Now, I haven't really shown you guys how to do that yet. So, I mean, we could do it. It's a negative exponent issue. So if you wanted to, this is what that is. So, but it requires chain rule, which I haven't really talked about that much yet. So, anyways, all right, one more. This one looks like potentially the easiest one. So it's a limit as h goes to 0, x plus h squared minus 2 times x plus h. Put that all in parentheses. Subtract parentheses x minus h squared minus 2 times x minus h. So you guys set it up all over 2h. So now, I don't think we necessarily need Pascal's triangle for this one, because x plus h squared, I can do that in my head. That's going to be x squared plus 2xh plus h squared. Pascal's triangles would work. And then you got to distribute this. Minus 2x minus 2h minus, this is going to be x squared minus 2xh plus h squared minus 2x plus 2h. Should still have the limit written in front. And then, so here, the x squared and the minus x squared cancel, because you got to distribute all this stuff. The 2xh minus, that's going to be a positive 4xh. And then the minus 2x, the h squared and the minus h squared, those cancel. And then the minus 2x and plus 2x, those cancel. And then the minus 2h minus 2h, does that up minus 4h over 2h. So then we're going to factor, we're going to factor at least an h out of everything on the top. And that way the h's cancel out. And then we're going to plug h equals 0 back in. And I think all the h terms are gone. Distribute the division. It should be 2x minus 2. And if you test it out, derivative of x squared is 2x. Derivative minus 2x is minus 2. Perfect. So that's kind of work I want to see in those. Those are kind of tough. Name and sketch the 3 primary types of discontinuities. So discontinuity could be a hole in the graph, could be a jump in the graph. So draw and name them, or it could be a vertical asymptote. So something like this, maybe. Name and sketch them. Okay, all right. 25, sketch function for which its graph is continuous but not differentiable. Continuous, so these are all discontinuous, but we want it to be continuous but not differentiable, which means the slope doesn't exist, which means it's got to be some kind of sharp change. So like a cusp, right? Or, you know, a corner, right? There's even another one. I don't know if I've shown you this. Some curves might look like this, where they have a vertical tangent and they're continuous and they're even smooth, but it's an infinitely steep slope, so the slope doesn't exist. So this one's about the 2 sides not agreeing. That's why the slope doesn't exist. The 2 sides agree, but the slope is infinitely big, so it's not defined. It's not differentiable technically. Okay, find M and B. We've done a few problems like this, so it's continuous and differentiable. So the first thing for continuity is we want the y values to equal each other, right? Y values equal, so we're going to plug 3 in, and 3 cubed is 27, minus 3 times 9 is 27, plus 10 is 10, and this is going to be 9m plus b, and then these have to be equal to each other. So 9m plus b equals 10. Now, I can't solve for m and b yet because there's 2 unknowns, so we need 2 equations. So then we bring in, for it to be differentiable, means that the slopes have to be equal at that transition. So I'm going to find the derivative piecewise. It's going to be 3x squared minus 6x for x less than 3, and then it's going to be 2mx, and b is just a number, so the derivative of b is just 0. And then I'm going to plug 3 into that, and I'm going to get 3 times 9 is 27 minus 6 times 3 is 18 equals 9, and I'm going to plug 3 into this, and I get 6m, and these got to be equal to each other. So 6m equals 9. So then I could solve for m, divide a 3 out, simplify it. So that's one of my answers, and then I could plug it in over here to solve the rest of the system of equations and find b. So b equals 10 minus 27 halves, so b equals negative 7 halves. There you go, little system of equations. And then these ones, if it looks like a duck, walks like a duck, talks like a duck, then it's probably a duck. If it looks like a derivative, acts like a derivative, smells like a derivative, it's probably a derivative. These are, you should be like, oh, this is a derivative. What's the function we're taking the derivative of? It's there twice, x squared with x plus h and x. These are right-sided difference quotients, by the way. Then take the derivative just using the rules that you know. 2x, and you're done. Okay, this one, what's the function? It's 2x to the fourth. Look right there, it's 2x to the fourth. 2x to the fourth with x plus h in it. What's the derivative of it? 8x cubed. That's it. All right, 29 we did together. It had numbers where the x's are. Only difference is you plug in the number when you're done. This one right here, the function is the square root of x, which you should think of as x to the 1/2. It's a power rule. So you're going to multiply by the power and decrease it by 1. And then probably write it a little nicer for your final answer. 1/2 square root of x. This one, this is where the x's go. Ignore the 9's for a second to say, okay, well, the function is 4 square root of x, which is 4x to the 1/2. The derivative of that is going to be 4 times 1/2 x to the negative 1/2 power rule. And then we could clean it up. We could say it's 2 over the square root of x. And then we want to evaluate it at 9. That's the big difference when you see a number there. You're going to get a number for your final answer after you find the rule. 2 grids. There you go. That's it. Bunch of good practice on that.